So, ladies and gentlemen, good morning, good afternoon, good evening, whoever you are, wherever you are. My name is Michael Mьorfі. I'm an American living in Kyiv. My email address and social media are in the chat there for you. Please feel free to reach out with me after this presentation if you have follow-up questions or comments or ideas for how I can better assist the Ukrainian people while I am here. Today, I am hoping that we can take advantage of the over 40 years that I have spent in the technology business to expand our understanding of today's cloud services environment. And so this is called Understanding Cloud Services 101. And I'll tell you, I could not be more grateful to Ksenia and everybody at 1991 that on this day of all days, July 4th, we could be doing this. It gives me a great deal of pleasure to be here with you today. All right, so let's take a look at what we're going to talk about. I want to start with a basic terminology and background so that we're all on the same page and we agree on the language. And then we want to take a look at the two big cloud services providers. They are AWS and Azure. And then I'll reference, there are some other players in the market and there are some other options. And so we'll mention third-party cloud services providers as well. Unfortunately, I was unable to find any Ukrainian-based cloud services providers. If anybody is aware of them, shoot me an email, but I'm not aware of any Ukraine-based cloud services providers at this time. And then lastly, we'll wrap up with preparations to deployment and an official Q&A section. But guys, I am not opposed to questions as we go along. If you have a question, you can put it in the chat. My chat is open. I should see it. And if it's appropriate to respond to it in real time, I will gladly respond to it in real time. If it's more appropriate to hold it, I'll hold it to the appropriate time and then throw it in there. But please don't hesitate. Particularly because I'm delivering this section in English, if I say something or use language that is confusing or that you are unfamiliar with and you want me to repeat or clarify something, please do not hesitate to ask for that clarification in the chat. I appreciate it. Thank you. Okay, so let's start with the basic terminology. And what I'd like to do is I'd like to take you through the last 40 years or so, the evolution from microcomputers to the cloud. Then we want to take a look at the dependencies. What are the underlying technologies that enable cloud services that we would not have this world without? The benefits of those cloud services, how we kind of bucket data center services, and then the solutions for redundancy, scalability, and failover. And we'll take a look at those. So the first thing is, now I can see looking at you guys, there is nobody here that's as old as me. I remember when I was the youngest person in the room all the time, and that time has long since passed. When I started in this business, all of your resources were located in your building. There was no other choice. And back in the B9100 days and the AS400 days and the VAX VMS days, you were isolated. And whatever services you provided on premise. This, of course, changed when we got the internet. And when we got, well, first we got the microcomputer. The microcomputer came into the office, these little computers sitting on people's desks, unconnected to everything else. And then, let's see, when was that? 1996. Microsoft released Windows 95 version B that included, bundled with it, Internet Explorer, and everything changed. It was like overnight, everything changed. The World Wide Web had only been live for about 4 years. I remember when the World Wide Web went live in April of 1992. Before that, the internet had been text-based only. In 1992, I was a principal in the 6th cyber cafe in North America. We served the community as a dial-up ISP. And we had just gone to Toby Hanna Army Depot and bought a bunch of those old military surplus green screens. You guys ever see them? The kind that the image would burn into the screen. That's why we invented screensavers in the first place. And it was about 3 months later that the World Wide Web went online and the internet suddenly had pictures and graphics. And these screens were worthless. It's a good thing we only paid $10 for them. The first thing that happened, of course, is web server farms. You got web server farms, you got web hosting. Everybody needed a website all of a sudden. Between 1996 and 2000, everybody went online. Big data, the age of big data came in, and we had data centers that would store and house that data. And we would connect to that data from our internal systems, or we would use it as a backup repository. This today has matured into, for many of us, for most of us, a hybrid cloud environment where our on-premise resources are integrated, backed up, redundant, and failover to the cloud resources. And this is the world that we want to live in, or something like this. And one of the things that we're going to talk about today are the options for this integration. Folks today have the option of moving to a cloud resource only environment, where internal on-premise, you have basically what we can refer to as dumb devices. These dumb devices will support a virtual desktop environment. There's really nothing on the device at all. You log into it, you connect over the public internet to a secure private cloud where a virtual machine is running your desktop operating system and all your applications and all your services and all your databases. And then what you get on your dumb device are really just screen scrapings, right? We're just looking at the visualization of the virtual desktop environment that's living out in the cloud. The benefits of this kind of structure are many, and we'll talk about some of these benefits as we work through this. You can probably guess what the first one is: cost efficacy. You don't have to spend money on hardware. You don't have to buy your own servers. You don't have those CapEx costs. And I'm sorry, CapEx is a term that we use in the United States for capital investment costs. Those are the costs of hardware, the costs of property, the physical resources that you have to spend money on and own in order to do business. Today, you have the opportunity to eliminate those capital investment expenditures and instead spend your money on OpEx, operational expenditures, by leasing cloud services time from a virtual desktop provider or a cloud services provider like Amazon Web Services or Microsoft Azure services. None of this would be possible without these technical realities. That we have high speed, always on, always connected internet connections. And that's something that's been really impressive to me here in Ukraine. The nature of the internet service provider community here in Ukraine is one of the most vital and distributed systems I've ever seen. And it means that even though your infrastructure has been the repeated object of attack after attack after attack, the internet remains up and running, generally speaking, and it's good. So that's been really impressive. That's been one of the most impressive things to me since I've been here in Ukraine. I don't know about you, but in my house, I'm never right for 45 minutes in a row, let alone for 45 years. But there was a fellow, Robert Moore, who worked at Intel. And back in 1967, he said that he would be able to double the number of transistors on a chip while having cutting the size of that chip in half every 18 months. And for the most part, that guy has been right since 1967. Just about, we're about at the upper limit of that now. And to get faster, we need to look at quantum computing. But the reality of Moore's law, which if you're not familiar with Moore's law, that's Moore's law, that in 1967, he said we would double the number of transistors on a chip and have the size of the chip every 18 months. The reality of Moore's law is that he's been right pretty much since, that's 55 years now. And the reality of that scaling architecture has consistently driven hardware costs down, enabling the creation of the modern data center. So now we've got cheap, scaled hardware with always on high-speed connections, right? What do we mean when we say high-speed connection? From Kyiv to London and back again in less than 500 milliseconds. That's the round trip time. And finally, the third critical component of the modern data center is hardware-assisted virtualization. Without hardware-assisted virtualization, we don't have, and to be clear on this, guys, right? I would assume that most of us are from, can I do a poll? Well, all right, let's not do that right now. Folks, at any point in this conversation, if you have any feedback, don't hesitate to put it in the chat, or jokes, as Dan Lowe has done here. Thank you, Dan. Hardware-assisted virtualization means that on a single machine, on a single piece of hardware, I can have entire operating systems that are file-based. It's just a file. That file can be migrated in real time to other pieces of hardware without ever interrupting the service provided by that virtual server or that virtual desktop. Hardware-assisted virtualization combined with declining hardware costs created, and of course the always-on, always-connected internet, created the rich, fertile soil for a migration to the cloud that enables the modern internet. And we're going to talk about how you can take advantage of all that for the rest of our time here. But that's the history, so that we're all on the same page with that history. In terms of what this means to all of us, it means, right, in the old days, when you had a physical server in the back, if that server went down, you had problems. Maybe you couldn't do business until you got that server back up. Today, that's hardly an issue. We've got agility. We've got the ability to migrate servers in real time without ever interrupting service. We've got elasticity. That is to say, we can do things like cloud bursting. You are going to run a promotion, and normally your website gets 10,000 hits a day. But when you run this promotion, suddenly, beyond all expectations, or because of some viral event on the internet, your servers suddenly need to process 1 million hits a day. What happens? We can automate the process by which new web servers are spun up and scaled, and those service requests get answered, right? We call that cloud bursting. And it provides for an elasticity that we've never had before. You've got pay-as-you-go cost efficiencies. Rather than making those large capital investments in server hardware, in T1 lines of your own, you can pay a cloud services provider for just what you use. And so you use a server so many hours a day, you pay for those hours and nothing more. That's the idea. And then, of course, of particular interest, I would think, for those of us here in Ukraine, is the ability to do global deployments at one time, the same day, across the public internet, across continents. And when we look at AWS and we look at Azure Web Services, what we see is a global infrastructure that lets you roll out new services, websites, and resources across all the continents that there are, depending on how you count continents. When we think of the buckets that the modern data center provides, the services that the modern data center provides, this is how we want to think. We want to think about infrastructure, not physical servers anymore, maybe not even physical clients anymore, but rather infrastructure as a service. My virtual desktop environment hosted in the cloud, my virtual servers and those virtual networks hosted in the cloud. Platform as a service. If you're a web developer, if you're a Java developer, if you do everything with Python or Ruby on Rails, you can get a full service development and testing environment in the cloud without ever having to manage the underlying binaries. They get managed for you. That's the beauty of platform as a service. And then finally, when your developers have produced those solutions, you can distribute the solution to your consumers with software as a service. All these little web apps that you can download from the iPhone, the Apple Store and the Microsoft Store, all those tiny little packages, they're not doing anything. They're not doing anything except connecting to a back-end resource that's housed in the cloud, a full-fledged top-to-bottom solution that's hosted out there on these fault-tolerant, scalable, load-balanced servers that may be virtual or may not, or may be physical, but they're out there somewhere. And even if your section of the internet backbone goes down, users can connect to any internet connection and get access to those services on the other side of the globe. That's the world we're living in today. And then for those of us that are interested in the modular nature of APIs, operating systems, and the deployment solutions today, we can kind of break this out on the far left of the screen. You can see when you've got a software solution that you build and manage in-house, you're responsible for managing all the layers, right? From the physical network layer, the communication channels, all the way up the stacks to the application layer. This goes away when we look out at cloud services provider solutions. If you've got a package, well, first of all, there's our network. The network that we run on, the virtualization, the servers, the storage, the networking components, all of that can be outsourced to the cloud services provider, and it's simply provided for you. And then you just need to worry about managing from the operating system layer up. If you're in the development business, you're developing software solutions, everything from the networking layer up to the runtime binaries can be managed by the cloud services provider. And you're in a world where you only need to manage the data and the applications, your development environment, and you develop your, well, generally speaking, these days, a containerized solution, right? Do you guys, are we familiar with containers and containerized solutions? Yes, yes, yes. Okay.
Yeah.
Thank you, sir. I appreciate that. And finally, of course, those solutions, the entire management of the solution, your software as a service, like all those apps that you download to your phone, can be outsourced to the data center and to the cloud services provider. And that's what we see with the SaaS solution there. Now, of course, you've got control. If there are things you want to manage, that can be arranged, particularly in what we talk about as a private cloud solution, which we'll come to in just a minute here. Redundancy, scaling, and failover. Now, what I've got here, guys, is basically a list of all of the things that we do to provide for redundancy, scaling, and failover, and all of the services that we want to be redundant, scaled, and have a failover solution for. And these include things like load balancing, cloud bursting, auto scaling, redundancy for our application servers, our websites. And generally speaking, if you're in this session, I would think most of us are familiar with these things. It all goes back to ensuring that our services, which are what drive our businesses today, are always available. And of course, if anybody is unfamiliar with any of these, don't hesitate to shoot me an email. I'll get you some resources. But we'll see some of these in some of the diagrams that I have coming up here. It all started back from the days when we only had microcomputers on the desktops, with a need to provide data redundancy. People would create files and then they would lose them, right? As a kid in college, I worked the help desk in the computer labs. And where I spent most of my time was trying to rescue files with data recovery tools from failed floppy disks. Those days are long gone. Today, we live in a world where our file servers live in the cloud. Those file servers are virtualized. They are distributed with copies of themselves to multiple locations, clones of those file servers. And then we track the version changes to documents as those changes are made. And if a data center goes offline, we fail over to a redundant copy of the data somewhere else. Much of the history of the last 30 years has been all about providing redundancy and scaling in this new world. And today, of course, there are multiple cloud services providers that you can work with. Those cloud service providers have redundant failover solutions within themselves. So my data can be hosted on multiple AWS data centers across the globe. And if one data center is out, I can fail over to another. But today, we think too about redundancy in our cloud service providers. And there are multiple third parties out there that have created redundant failover solutions so that, God forbid, AWS or Azure comes under some systemic denial of service attack or other ransomware attack, and that service is down, you can fail over to the other one. And this is a kind of niche solution that's out there today. But from the days when we went to redundancy for single files, we now live in a world where we have redundancy, automated failover solution, and automatic scaling for our entire infrastructure and all of the applications and services that we provide. And this is a very exciting world to live in. And if I may suggest, guys, it's a world that nobody has ever lived in before. We're living in a world where these solutions provide new opportunities for those who can innovate in this world. And I'll tell you, I've seen some remarkably innovative examples of new technology emerging here in Ukraine. And I don't want to overstate it, but I do believe that when this war is over, we will see a new innovation tech center emerge here in this country. And all of you are part of that. So that's the basic terminology. That's the introduction to cloud services. It gives us a little bit of history, an understanding of the dependencies, the components of the modern data center and their services, as well as redundancy, scaling, and failover. Does anybody have any particular questions on any of that?
Yeah, Michael, I have a question regarding slide where you described like several stages for cloud infrastructure, like infrastructure as a service, platform as a service, and application as a service. Yeah, this the next one. Can you please explain, maybe using some AWS services as examples? Can you explain all the stages? If I correctly understand, like infrastructure as a service is just a basic level. For instance, if you're just using EC2 instances, something like that. But can you provide some sample on platform and software as a service?
Alex, can you bear with me for about 5 slides? And we're going to talk about EC2. We're going to talk about Route 53. We're going to talk about, yep.
Yeah, makes sense.
It's coming right up. So this is a generic look at those buckets that you should expect any cloud services provider to be able to give you, right? Now we're going to take a look at AWS and Azure and the specific branded solutions from each of those cloud services providers. Fair enough?
Yeah, sounds good.
Thanks, Alex. I appreciate it. AWS. And thank you, Dan. And Alex's question, if you're not familiar with AWS, which obviously Alex is because he asked about EC2, we can see one of the things on my list here is AWS services. And we're going to talk about those coming up right now. let's take a look. We'll kind of give an overview of the AWS solution, cloud workload architecture, the regions and locations, the services, and Cloud Map. Alex, have you heard of Cloud Map or have you used it yet?
No, to be honest, I didn't use it before.
And dude, that's perfectly understandable because it's a brand new service from AWS, and we'll talk about what it's for and what it does. I was very happy. I'll tell you just as an aside, guys, I was very happy when I sent the AWS portion of this deck to my buddy who's an AWS expert. Because Cloud Map is so new, he has not used it either. So he sent me back a note saying that he learned a bunch and he was excited for this presentation. So I appreciated that. One of the things that AWS wants you to know, and I included this slide simply because AWS includes it in every single one of their AWS presentations, is that AWS is not an all or nothing solution, right? That we've got tight integration of our cloud resources with our on-premise resources. And this extends to Active Directory, the users and access rules in the cloud. It translates to the users and access rules in the cloud. Now, the reason I think that AWS wants to stress this is because Azure's great advantage in the marketplace is that it's owned by Microsoft. And does anybody know how many of the top Fortune 5,000 companies have Active Directory domains? Can anybody guess how many of the Fortune 5,000 have Active Directory domains? The number is 5,000. And so because of that deep integration of Microsoft authentication and authorization services, as well as the deep integration of Active Directory with Active Directory, Azure Active Directory, one of the competitive advantages that Microsoft has is that reality. AWS needs to compete with that, and their solution is users and access rules. But the integration with your on-premise solution goes well beyond that, so that there is a network configuration, encryption, and backup appliance equity. And so all of these on-premise solutions that I've been used to managing integrate into my AWS solution. Here we see AWS claims that it supports any cloud workload. And Alex, this goes to your question. We know that AWS will support any of these, but tell me, please, which of those services map to which of these features? Am I right? Is that basically the question you asked?
Yeah, exactly.
Thank you. Thank you. I appreciate that. Real quick, here's the, I hope this is displaying for you guys okay. It looks a little funky to me. But these are the AWS European regions, and this goes to the point that AWS has a strong presence here. Each of these regions has multiple data centers with, I would quote a number, but the thing is, every time you quote a number, AWS expands more and the number's out of date. But there are literally thousands and thousands of servers and virtualized servers available for you to leverage out there, as well as edge cache locations. And when we think about the caching of data, what we're talking about is a delivery system that increases the throughput, right? That means responses get back to the clients faster. So you pull some data and it has to come from the server. The next guy who goes to pull that data the data's already been cached at an edge location. And so we don't have to make that call to the back-end server again. We can simply deliver the data from the cache. Does that make sense? And this has scaled for AWS globally. I apologize. That slide's out of order, guys. I'll go back to that in a second. Now, Alex had asked the question, Murph, can you talk about the services? And here we see EC2. That was the first question you asked, Alex, right? And essentially what that maps to is infrastructure as a service. Those are your virtual machines. So I'm managing virtual machines, I'm managing virtual servers, and I'm managing the applications and services that those servers run. And I'm doing that all in the cloud. I'm connecting to those virtual servers via an RDS connection or some other proprietary or encrypted connection. We could extend our understanding of that virtualized infrastructure as a service solution with the elastic load balancer down there, the ELB choice. Now, when we think about load balancing, we're talking about a mechanism by which incoming client requests can be load balanced across a number of virtual servers or a number of physical servers. But in this instance, those EC2 solutions are going to be virtualized. And so I've got a front-end load balancer that distributes client requests across the back-end virtualized machines. And that's the IaaS portion of this bucket. Let me know if we're making sense so far. That's built. Thank you. I appreciate it, Daniel. That's built on top of VPC, the virtual private cloud. Now dig it. That virtual private cloud includes your networking components, and it is an isolated private cloud environment. For many of us, we want our cloud services to be publicly available to all those folks out there that have bought our application or have downloaded our app to their phones, or to our web servers or websites. All of that is public. But sometimes, most of the time, right, we've got proprietary data that's got to be held securely and confidentially. I'm unfamiliar with the European privacy regulations. I know there's such a thing. I can't even remember what it's called right now. I should have brushed up on this before this call.
GDPR.
Say it again.
GDPR.
Thank you. That's the one. Now, in the US, what we talk about all the time is HIPAA compliance. That's the big privacy concern in the US. But there are companies that specialize in providing these solutions and building cloud secure solutions that keep your data compliant. Simple Storage Services, S3, is the kind of low-end data file server solution, providing file services, redundancy to file services, and load balancing across file servers, all in the cloud, and would map to, well, it could map either to infrastructure as a service if you were maintaining your own file servers as virtual machines, or if I were doing that through a software-based solution, it could be a software as a services solution. Same goes for relational databases. In the private cloud, now, what my understanding of what AWS offers is a relational database service that supports MySQL, SQL, Oracle, any number of database solutions. Those database solutions, those relational database solutions, can be delivered as a full-fledged software as a service solution where all the elements from the data backend and the storage network are managed by the vendor to the front end of application that's also distributed and updated by your vendor. You would develop the application that attaches to the relational database solution in a platform as a service offering. So in the platform as a service offering, we have a fully functional software development and testing environment where we produce our solution and then we package it up generally as a container object and distribute it in a software as a service solution. All of this, of course, is dependent on your clients being able to find the resources. And that's where DNS and Route 53 and Cloud Map come in. DNS is the traditional naming service that resolves IP addresses to services, right? And AWS offers a full-fledged, globally deployed and managed DNS solution for all of your cloud services. But much more importantly than that today, they have an offering called Cloud Map. And Cloud Map provides a registration solution for registering names for application resources that are discoverable. Now think about this with me for a second. Well, first, just before we talk about Cloud Map, Alex, I'm not sure I answered your question or if that was enough of an answer to give you a sense of where those services fall. Do you have any follow-up?
Yeah, I follow up just now thinking about this Cloud Map. It sounds like a service registry, I guess. There is a tool called, I don't remember, developed by HashiCorp Console, I think, that did the same job before.
I don't know that solution. When I think about Cloud Map, you know what I think about, because I'm old, I think about NetBIOS naming conventions. Does anybody remember NetBIOS naming conventions? Is that something anybody here is even old enough to remember? We got rid of it so long ago at this juncture, but when Microsoft first started networking, their solution for finding services on the network was called NetBIOS. And what it did was it let me provide friendly names for things like databases, queues, microservices, and other resources on my network. Friendly names that would map to a socket. What's a socket? Can anybody tell me what a socket is? Look at you, you're smiling down there from ear to ear because you know the answer, Alex, right? But what, you're not going to say anything? All right, fine. That's fine. A socket.
I can tell.
Go ahead. Help us out here, pal.
This is what we got problems recently, maybe last few months. So I will not.
You've been having problems with sockets?
Yes. So maybe let's meet in a week.
What happened? You stick your finger in one?
Okay, go on with your lecture. Let's
Thank
talk.
You, Alex. To put it simply, a socket is an IP address plus a port number. And so it's a mapping to a unique machine on a unique network and to a unique service on that unique machine. right? Does that make sense? And that's what NetBIOS did. Now, in so many ways, that's what Cloud Map Service Discovery does as well. And to Alex, to your point, I'm sure that there are other solutions out there that do this same thing. I'm just not familiar with the one that you mentioned.
Yeah, just shared it in the chat.
Console.io. I'll take a look at it. Thanks, pal. So how does Cloud Map work and what are some of its features? It creates a world in which your clients can discover resources either via an application programming interface, an API call, or through DNS queries. It provides, this is the problem that we have, right, as human beings. As human beings, we are not great with numbers. We're good with names. And of course, the numbers, the underlying IP addresses, even the port or service assignment numbers for our applications and services can change over time. So what we want, instead of having to call or specify in our programs or in our development process an IP address or a specific port number, we can instead create a unique name for that service, for that resource, for that call, and use that name or that label in all of our development activities. And then when the application calls that friendly name, the cloud mapping service in the background translates that name to the current IP address and port number and connects us to that resource. So that if you've got a data center that's gone down and you've got to fail over to another data center, the failover, the calling of the name becomes automatic. The translation of the name to the new IP address becomes automated. And that's a thing of beauty. That's a thing of beauty. And what we see here is that the solution is fully managed on the AWS end and provides for rapid change propagation. So that if you've got a failover solution in place and you've got to fail over to the other data center, the propagation of the change happens in near real time, which is a benefit that I don't know that anybody else is providing right now. I don't know that the Microsoft solution works with the same efficacy that the Cloud Map solution does. I'd have to take a look at that. I'm not sure. What, for the developers out there, what you're really looking at here is a world in which application availability and your productivity are enhanced because you can reference that friendly name in all your development activities. Some of the use cases for this include just simple service discovery, right? Where are my services today? Continuous integration and delivery, and an automated health monitoring component that ensures that the system is up and working and that those calls are being answered in a timely manner. This here is that the front end service provides a dynamic lookup for those back end services. And just an FYI, I got a warning on my screen here that my internet connection is unstable. If my camera freezes or anything, that's happening. See, that's what I get for lauding how reliable the internet has been here in Ukraine in spite of everything. So what we see is that in the past, I would have to change the code. I would have to update the references in the underlying program to the changes in the resources on the back end. Today, with the front end service there, we have a dynamic lookup for that. The endpoint gets updated from version 1 to version 2. The dynamic lookup to Cloud Map finds the location of version 2 and connects the user to the new endpoint. And this dynamism is the great advantage of Cloud Map in the AWS service today. Questions? Can I address anything in there? Because that takes us to the end of AWS.
Yeah, I have a question regarding DNS resolution in this case. I believe that you have to, if you're gonna use Cloud Map for your infrastructure, you will have to specify like custom DNS server for each EC2 instance, because I believe that this Cloud Map service, it uses like some internal DNS server. And in this case, your EC2 instance will have to target this like internal DNS server, right? To pick up all quick updates and so on. Correct.
Now, my understanding of this, Alex, is that think of the infrastructure as a service solution, right? Where you've got virtual machines that host your services. And then on these internal virtual networks hosted in the cloud, your servers live, and they provide the endpoint services. Dig? What you're gonna do is you're gonna use either a simple split brain DNS scenario, so that external lookups are directed to external DNS servers, while internal lookups are directed to the internal servers, or you're going to use a DNS forwarder. And so your clients always point to an internal DNS server, but in the event that they have a request for an external resource, those get forwarded to the DNS forwarder. Does that make sense?
Yeah, makes sense. I expected like similar behavior, so it acts as a proxy when you are requesting external resolution.
Now, see, I'm a Microsoft guy, so a proxy server is a very specific thing to me. Can you think of the DNS forwarder as a proxy? Sure. Yeah, no, I'm fine with that. Yeah, I agree. Follow up? Okay. Vasil, thank you. Thank you very much. I appreciate it. Thanks for being with us for a while.
Have a good day. Thank you.
Thanks, Vasil. Okay. So now the reality is that the AWS solution looks very much like the Azure solution. The great advantage to the Azure solution is for those folks who live in a Microsoft world. If you live in a Microsoft world, you're going to find that your transition to Azure is seamless. The integration is deep. But if you live in a mixed environment, AWS offers all kinds of perks for that. That seems to be the consensus understanding in the marketplace, at least from what I can see out there. The Microsoft Azure Compute solution, right, similar to the EC2 solution, includes those virtual machines, those VMs with infrastructure as a service. It includes cloud services and application delivery services. And this happens, I can deliver enterprise-grade web applications using standard APIs in the Azure App Service to develop, publish, manage, and monetize those APIs. I can build mobile apps, platform as a service, if we use the generic industry term, native and cross-platform apps for Android, Windows apps, or cross-platform. And currently in preview is something that Microsoft is calling logic apps that allows developers to design workflows that articulate intent via a trigger and a series of steps. What this really is an extension of the Microsoft AI solution. Now, I'll tell you guys, I personally have not looked at the Microsoft AI solution yet, and so I cannot speak to it. But my understanding is that this is the future and something that we should all be looking at, myself included. Microsoft calls its scaling hyperscaling, global hyperscaling. Now, is it that much different from the AWS solution? It is not. Multiple data centers around the globe with thousands and thousands of servers that you can host your solutions on. And a pay-as-you-go solution as well. What is different, I think, in the Microsoft world is their new emphasis, their new security paradigm that emphasizes a role-based security solution. Now, what this means is that for my virtual servers hosted in the cloud, they may have the IIS components installed and provide web services or the web role, or they may have a specific non-IIS enabled role, a worker role that does not require IIS, though today many of these web roles do. Now, what's interesting about this role-based approach is that it extends to the user. And so today I can construct roles that are associated with Azure Active Directory accounts and simply assigning that role to a user account and linking that Azure AD account to an internal Active Directory account means that you have just the amount of rights that you need to perform particular functions on particular servers or services in the cloud solution. And this is a very tight, very locked down world to live in, where I can limit what you can do based on who you are and what services on what servers. I can be server specific with this role. And that's a new world to live in, but it allows for a very, very fine-grained control of the security mechanisms and the security paradigms. Highly scalable. I've got RDP connections to the back end for the management of those servers. And cloud services can also contain virtual machines as infrastructure as a service in a classic view. Virtual machine services includes the compute resources, that is to say the virtual machines and the virtual machine extensions. Virtual machine extensions allow for things like shared clipboard, shared resources, shared hardware, etc. The back end, the storage resources, binary large objects or blobs. These are binary files with lots of data in them, all stored in binary. Storage accounts. There's a standard and premium storage, and this affects how much you're going to pay, and it also affects the availability and the redundancy in that back end. You can build your own virtual networks, network interface cards, load balancers, IP addresses, and network security. And this is what that looks like. Now, again, what I see here is I see that on the back end, there's my storage account or my storage resource provider, the SRP. That storage resource provider manages the back end storage. Those are my disks, my disk arrays. Then I've got a compute resource provider. And that is a distinct VM that connects to the back-end storage arrays. And this includes the use of storage spaces, which is a Microsoft storage, virtualized storage solution, if you're unfamiliar with storage spaces. Then you've got a network resource. And the thing about this, guys, that can be so hard, I think, to get, is that none of this needs to be physical. It's all virtualized today. I've got what looks like a map of physical resources, and it's true that underlying these resources is a physical network, are physical machines. But those machines are going to tend to be hypervisor-based machines running my virtual machines as a workload, as a virtualized workload. And physically, the data itself is stored on a back end that's virtualized as if it were a physically installed disk, but it's not. It's a highly available redundant array on the back end that the virtual machine, which thinks it's a real machine, sees as if it were internally attached storage, which it is not. The network cards don't even tend to be real. They tend to be virtualized and associated with network load balanced or teamed NIC cards. And then in front of all of them can be a physical hardware load balancer or a software-based load balancer that takes incoming client requests, load balances them across the virtualized teamed NICs, up the stacks to the virtual servers that attach to the back end to pull the data from the server and deliver it to the client. That's kind of the world we're living in today. And that's a look at Azure. And I hope that the mapping of those services to the AWS versions is clear. If not, this deck will be available for everybody. Anybody can hit up Ksenia or Ksenia will post it somewhere where you can get it. And you can go through it and you can map them to each other. Now, as I mentioned, in addition to the big two providers, there are third-party providers. Now, why would you choose a third-party provider? Well, maybe because you have some need for custom solutions in a boutique services environment that you can't get out of an AWS or Microsoft solution. Commonly, for folks that are in a situation like that, one of the things that I see folks doing is they start their own cloud service provider with themselves as the single client. And so you spin up a wholly owned subsidiary that's got its own data centers, and it starts out with you as its client. And then maybe over time it evolves to take on other clients. Generally, these will be industry specific and will provide solutions only within that industry. This is particularly true in financial services. There are a couple of these providers in downtown Manhattan that provide very unique custom solutions to the financial services industry. And when they take on clients who are not their owners, it tends to be clients that they have deep and long-standing business relationships with. And so a boutique hedge fund may spin up its own cloud services provider to provide its own internal solutions. And then over time, it scales those solutions to other hedge funds who it has deep business relationships with. This is what I see in the marketplace. I don't see too many people going up against AWS and Azure. If anybody knows of anybody, I'd be interested in hearing about it. These links, go ahead.
Yeah, I have just a small addition. I think that you're still missing the third cloud provider. It's a Google Cloud Platform. It's also like widely used. And as for me, the main reason why personally I like using it, because they have a managed service for Kubernetes, like Google Kubernetes engine. And since Google is a company that maintains Kubernetes, they have the first-class support for this platform. So that's the reason, for instance, I prefer it for some tasks.
I apologize, Alex. You couldn't be more right. I did miss that. And I missed it just because it's not on my radar and I've never used it, never been in there. And I wish I'd had this conversation with you before I did this. I would have done some research and included it. But you're absolutely right. That would be the big three.
Yeah, agree.
I'm not sure about Oracle. Danielo mentions Oracle, and I don't know, is Oracle doing this?
I think they do. I'm not sure about the scale, and I haven't worked with it, but I've heard a lot of things about Oracle. So yeah,
I'd have to look.
Yeah, same here.
But I definitely agree with Alex. As soon as he mentioned Google Cloud, I knew that to be true. But Oracle, I'm not familiar with at all. For anybody, and so clearly there should be a Google Cloud link on here too. And I'm sorry I missed that, guys, but it's a good point, Alex. Thanks. Both of the big cloud services providers have a number of tools that you can download that will inventory applications on your network, inventory servers and clients, and give you insight into what your current resources are prior to migration, as well as sets of tools to assist with those migrations to the cloud. And those can be downloaded. If you download the deck, the links are in there for those solutions, and you can take a look at the individual recommendations from each of those major cloud services providers. And that takes us to the end of the discussion, or the end of the deck